After studying this module, you shall be able to know the concept of time value of money, learn about compounding and discounting method of time value of money, identify difference between the nominal rate of return and effective rate of return, evaluate the future value of single flow, future value of multiple flow, present value of single flow, and present value of uneven multiple flow, present value of annuity, and present value of perpetuity. To begin with, it is assumed that when money is invested or received, irrespective of time, the value of money remains same. For example, value of 1 rupee at the end of 1 year is equal to the value of 1 rupee at the end of second year, and also equals to the value of 1 rupee at the end of third year, and so on. However, this assumption is wrong, as money has time value. The money on hand now has more value than the money receivable after a year. For example, rupees 10,000 now is more valuable than rupees 10,000 after a year. The difference between the values is because of the interest which is required to part with rupees 10,000 now. Generally, interest is expressed in percentages like 12% or 10% per annum. Now we will discuss about why should money have time value. Following are the reasons for this phenomena. Money can be utilized productively to earn real returns. For example, investment of rupees 1,000 in raw materials resulted into the finished goods worth rupees 1,100, where the investment of rupees 1,000 has earned a rate of return of 10%. A rupee today has more purchasing power than a rupee in the future. This is true in an inflationary period. People prefer to consume today instead of consuming in future because of future uncertainty. For example, a project has an initial investment of rupees 2 lakhs. Expected return is 50,000 per annum at the end of each year for 6 years. Here, the project has cash outlay of rupees 2 lakhs in 0 year and cash inflows of rupees 50,000 per year for 6 years. Now, for accepting or rejecting a project, a firm needs to find out the present value of cash inflows received for 6 years and compare with the initial investment of rupees 2 lakhs. Firm can accept the project if the present value of cash flows at the desired rate of interest exceeds the initial outlay of rupees 2 lakhs, or at least equals the initial investment of rupees 2 lakhs. The rate of interest can be calculated from the following formula. The nominal / market rate of interest is equal to real rate of interest plus expected rate of inflation plus risk premium to compensate for uncertainty. The methods of calculating time value of money are compounding method and discounting method. First method we discuss is compounding method. Under this method, we calculate the future value, in short FV, of all cash flows at the end of the period at a particular rate of interest. For example, initial cash outflow is rupees 1,000 and yearly cash inflows in the year 1 250, year 2 500, year 3 750, year 4 is 750. Now compare the future value of the immediate cash outlay of 1,000 rupees at the end of fourth year with the total sum of the future values of the yearly cash inflows at the end of fourth year. Second method we discuss is discounting method. Under this method, we reckon the value of money now, that is at time 0. Here, we compared the initial cash outflow with the sum of the present value within bracket PV of the future cash inflows at a given rate of interest. Therefore, if we take the above example, which has been explained under compounding method, we need to compare the initial cash outflow of rupees 1000 with the sum of present value of 250 plus present value of 500 plus present value of 750 plus present value of 750. Difference between compounding interest and simple interest. Under compound interest, interest earns interest, but under simple interest scheme, interest does not earn any extra interest. For example, if A has an initial investment of rupees 2000 and there are two methods. One offers a rate of interest 10% compounded annually and other offers a simple rate of interest of 10%. Which one should he opt for? Assuming that he will withdraw the money at the end of 1 year, 2 years and 5 years. Given the initial investment of rupees 2000, the accumulations under the two methods are, now look at the table. First column is end of year 1. Under second column is compounded interest method. Column 3 is simple interest method. At the end of year 1, under compound interest method, 2000 will become 2200. Under simple interest method, it also becomes 2200. At the end of the second year, under compound interest method, 2200 plus 2200 into 0.1 is equal to 2420. While under simple rate of interest, at the end of year, you will get 2200 plus 2000 into 0.1 is equal to 2400. Similarly, you can look at the end of year 3, 4, 5 in the table. From the above table, it is concluded that we get more value for our investment under compound interest scheme rather than under simple interest scheme. Next, we will discuss about the future value of a single flow. Future value of a lump sum amount invested at a point of time can easily be calculated by the above method. However, it becomes difficult to calculate the same for maturity period of 20 or 30 years. Thus, for calculating the future value of a single cash flow compounded annually, following formula can be used. The future value after the year n FVN is equal to PV multiplied by 1 plus K raised to power n, where FVN is future value of the initial flow n years hence, PV is initial cash flow, K is annual rate of interest, and n is the life of investment. 1 plus K raised to power n represents the future value of an initial investment of rupees 1 at the end of n years at a rate of interest K referred to as future value interest factor. In short, FVIF. Thus, to calculate the future value of any investment for a given value of K and N, the corresponding value of 1 plus K raised to power N from FVIF table has to be multiplied with the initial investment. Example: the fixed deposit scheme of XYZ Bank offers the following interest rates: period of deposit and rate of interest per annum. 46 days to 179 days, the rate of interest offered is 8%. 180 days to less than 1 year, 8.5%. 1 year and above, 10%. An investment of rupees 1 lakh today will grow in 3 years to FV is equal to PV into 1 plus k raised to power n. Here in this case, PV is 1 lakh. Rate of interest is 10%. So 1 lakh multiplied by 1 plus 0.1 raised to power 3, which comes to 1 lakh multiplied by 1.331, which is equal to 1,33,100. Doubling period. If an investor wants to know about the time period required for the amount invested to be doubled for a given rate of interest, then the following formula has to be used. Doubling period is equal to 0.35 plus 69 divided by interest rate. Example. Below is the calculation of doubling period for two rate of interest. If rate of interest is 5%, then doubling period is 0.35 plus 69 divided by 5, which comes to 14.15 years. If the rate of interest is 10%, the doubling period is 0.35 plus 69 divided by 10 is equal to 7.25 years. Growth rate. The compound growth rate for a given time period can be calculated with the help of future value interest factor table. Example. Determine the compound rate of growth from the following tables. In the row 1, you have years 1, 2, 3, 4, 5, 6. In the second row, you have profits in lakhs 90, 100, 130, 150, 160, 170. Now, there are two steps to calculate the rate of growth for the above table. The ratio of profit for year 6 to year 1 is 170 upon 90 is equal to 1.89. The FVIF table can be referred where we need to find the value which is close to 1.89 for the row for 5 years. The value which is close to 1.89 is 1.842 and the interest rate corresponding to this is 13%. Thus, the growth rate is approximately 13%. Now suppose compounding is done more frequently. For example, deposit amount of rupees 1 lakh in a bank offers 8% rate of interest per annum compounded semi-annually. Following is the way to calculate the amount at the end of 1 year. Amount in the beginning 1 lakh. Interest at the rate of 8% per annum for first 6 months is equal to 1 lakh into 8 divided by half is equal to 4,000. Amount at the end of 6 months is 1 lakh 4,000. Interest for second 6 months is 4160 and amount at the end of 1 year is equal to 1,08,160. Alternatively, FV is equal to PV into 1 plus K upon M raised to power N into M. FVN is the future value after N years. PV is the cash flow today. K is the nominal interest rate per annum. M is the number of times compounding is done during a year. N is the number of years for which compounding is done. So in our example, future value is equal to 1 lakh multiplied by 1 plus 0.8 divided by 2 raised to power 2, which comes to 1,08,160. If compounding is done annually, the amount at the end of year will be 1 lakh multiplied by 1 plus 0.08 is equal to 1,08,000. This difference of 160 is because under semi-annual compounding scheme, the interest for the first 6 months is interest in the second 6 months. Effective versus nominal rate of interest. In the above example, the accumulated amount under semi-annual compounding scheme exceeds the accumulated amount under annual compounding scheme by rupees 160. Under the annual compounding scheme, the nominal rate of interest is 8%. However, under the semi-annual compounding scheme, the growth rate of principal amount is 8.16%. This 8.16% is the effective rate of interest per annum under annual compounding. That has the same effect as at the rate of interest under semi-annual compounding scheme. Now, instead of investing the lump sum amount at a time, if we invest rupees 2000 now, beginning of the year 1, rupees 3000 at the beginning of year 2, and rupees 5000 at the beginning of the year 3, here we need to add the future compounded values of rupees 2000, rupees 3000 and rupees 5000 respectively at the given rate of interest. Below is the way to determine the accumulated sum at the end of year 3 at a rate of interest of 10%. Accumulated sum is equal to 2000 multiplied by FVIF 10.3 plus 3000 multiplied by FVIF 10.2 plus 5000 multiplied by FVIF 10.1, which can be simplified to 2000 into 1.331 plus 3000 into 1.210 plus 5000 into 1.100. This is equal to 2662 plus 3630 plus 5500. This will aggregate to 11,792. Future value of annuity. The above calculation becomes difficult when we need to determine the accumulation of multi-flows over a long period of time. In such cases, we can use a shortcut method provided the flows are of equal amounts. The future value of regular annuity for n years at k rate of interest is FVAN is equal to A multiplied by 1 plus k raised to power n minus 1 plus A multiplied by 1 plus k raised to power n minus 2 plus A multiplied by 1 plus k raised to power n minus 3 plus so and so plus A. This can be reduced to FVAN is equal to A within bracket 1 plus k raised to power n minus 1 bracket closed divided by k. A is the amount deposited at the end of every year for n years. K is the rate of interest. N is the time period. FVAN is the accumulation at the end of n years. 1 plus k raised to power n minus 1 divided by k is called future value interest factor for annuity. In short, FVIFA. And it says that accumulation of rupee 1 invested at the end of every year for n period of time at the rate of interest k. Thus, we just need to multiply the annuity amount by the appropriate FVIFA values to determine the accumulation. Example: A deposits rupees 2000 per annum at the end of every year as life insurance premium for next 20 years. Calculate the future value of annuity at 10% rate of interest at the end of 20 years. Solution: 2000 multiplied by FVIFA 1020 is equal to 2000 into 57.275, which is equal to 1,14,550. This approach is also known as discounting approach, which is used to determine the present value of a future cash flow. This approach is mostly used to evaluate the financial viability of projects. Below are the formulas to calculate the present value of a future cash flow. PV is equal to FVN divided by FVIF KN. This is equal to FVN divided by 1 plus k raised to power n. Or we can also write as FVN into PVIF Kn. Thus, we need to locate PVIF factor for a given K and N and multiply this by the given sum. PVIF Kn value can never be greater than 1 as it represents the present value of rupee 1 receivable after n years at a given rate of interest. Example: calculate the issue price of cash certificate having a value of rupees 1000 after 1 year at 10% rate of interest compounded on quarterly basis. Solution: effective rate of return R is equal to 1 plus K divided by M raised to power M minus 1 is equal to R 1 plus 0.10 divided by 4 raised to power 4 minus 1, which gets simplified to 10.38%. The issue price of cash certificate is present value is equal to future value divided by 1 plus K raised to power N is equal to 1000 divided by 1 plus 0.108 raised to power 1, which simplifies to rupees 905.97. If the project earns multiple inflows, then aggregate the present value of all cash flow streams and the project is said to be viable only if the present value of the cash inflows exceeds the present value of cash outflows. Example: an investment of rupees 5 lakhs generates net inflows as at the end of year 1 2 lakhs, year 2 5 lakhs, year 3 8 lakhs. Calculate the present value of the future cash inflows at 10% rate of interest. Solution: it is represented in this table where column 1 is showing year, column 2 is cash flows, column 3 is present value in lakhs. 1, 2, 3 is given years, cash flow is 258 and the present value is calculated in the third column 2 into PVIF 10.1 which is equal to 1.818, 5 into PVIF 10.2, 5 into 0.826 is equal to 4.130, 8 into PVIF 10.3 is equal to 8 into 0.751 is equal to 6.008. The total of these three is 11.956. The present value of the investment is rupees 11.956 lakhs, which is more than the present value of cash outflow, which was rupees 5 lakhs. Thus, the project is said to be viable. The present value of an annuity paid receivable at the end of every year for a period of n years at K rate of interest can be calculated by the following formula. PVA N is equal to A into within bracket 1 plus K raised to power N minus 1 bracket close divided by K multiplied by 1 plus K raised to power N, where the expression 1 plus K raised to power N minus 1 within brackets divided by K multiplied by 1 plus K raised to power N is called as PVIFA, present value interest factor annuity, and this indicates the present value of a regular annuity of rupee 1 for the given rate of K and time period of n years. Example: a lump sum amount of deposit is remitted and the principal amount is received with rate of interest of 10% per annum, compounded quarterly in 12 monthly installments. Calculate the initial deposit to receive monthly installment of rupees 1000. Solution: effective rate of return per annum R is equal to 1 plus K divided by M raised to power M minus 1 for 10% comes to 10.38%. The effective rate of return per month is 1.1038. Take the 12th root and subtract 1 from that. This gives you a rate of return of 0.00826, or we can say the effective rate of return per month is 8.26%. So for initial deposit amount, PVAN is equal to A into 1 plus K raised to power n minus 1 bracket closed divided by K multiplied by 1 plus K raised to power n. Putting the figures in this equation, you get 11,376. An annuity of an infinite duration is known as perpetuity. The present value of perpetuity can be calculated by the following formula. P infinite is equal to A into PVIFA K infinite. The value of PVIFA K infinite is equal to 1 upon K. Thus, the present value of perpetuity is equal to the constant annual payment divided by the interest rate expressed in decimal form. For example, if an individual buy British issued bonds known as consols from British government, the bond holder will earn an annual interest payment forever.
To summarize, money has time value in all situations: inflation, uncertainty, and opportunity cost. Today's money has more value than the money a year hence, and the difference between this is known as interest. So, without considering the interest factor, investment of the same amount in different projects for different time period cannot be compared. There are two methods for calculating time value of money. One is compounding method and the other is discounting method. Compounding method is used to determine the future value of current investments, and discounting method is used to determine the present value of future cash flows so as to compare these to the initial outflow. The rate of interest is generally the firm's cost of capital.